In this demonstration, I have set up ipv6 to v4 tunneling, and this is useful if, for example, your ISP does not support or does not provide you with ipv6 connectivity, and in that case you have to create an ipv6 to ipv4 tunnel to allow your network to reach the ipv6 global network. So first you have to request a tunnel from a tunnel broker, and they will provide you with a global ipv6 address for which to assign to your host or router, and also the destination endpoints of the tunnel, ipv4 and ipv6 address that you will configure in the router, as I will show you here. So I have my router already logged in or already created the tunnel. The first thing you need to do is to enable ipv6 routing via this command, and ipv6 forwarding, and then we create a tunnel. The tunnel ipv6 address will be the client ipv6 address that you see here. The tunnel source and destination ipv4 addresses. You want to enable ipv6 on the tunnel, and you want to set the tunnel mode as well. On my fast Ethernet interface, this is my outside interface on my Cisco router, which obtains a public ipv4 address. So I haven't made any change to my fast Ethernet 0 outside interface. However, on the internal LAN side interface, I have set an IP address that is the first address in the routed prefix. This is my network. So this is my internal network, and my LAN interface is assigned the first address on that routed prefix that has been assigned to me by the tunnel broker. Now you don't need to configure the inside interface. What I recommend is, once the tunnel has been created, you can go ahead and ping ipv6 address such as google.com, and you should be able to get replies. In the LAN interface, we have as well some other options. We've enabled ipv6. We've also enabled this flag, which tells the clients to obtain DHCP settings from the Cisco DHCP server. So on this interface, I have enabled an ipv6 DHCP server, which will provide the client with these ipv6 DNS servers. Otherwise, the client will not be able to resolve host names to their ipv6 addresses. So that's pretty much for the interfaces. As well, we have created a default route which says that to go to any ipv6 address, go through the tunnel 0, which has been created. So the router I'm using is a Cisco 1760, and it's a voice router, but it did support ipv6, so I chose to use that router. Some other commands we can run: Cisco show ipv6 route So it says here the default route for IPv6 address to go through tunnel 0. I can show IPv6 neighbors, which shows me all the addresses of clients on my network that have automatically configured themselves with a local IP address in the local route prefix that we talked about earlier. Okay. Some other commands. Show IPv6 interface. We see that, importantly, for the local interface, this is my global address, this is my subnet or router prefix, and on the tunnel, this is the tunnel global IP address, IPv6 address, and the network that it belongs to. So from the tunnel, I can ping the far side. Let's see if we get replies. Yes, I can ping an IPv6 host. So now let's look at the client side. IPv6 is supported natively on any Windows 7 machine or later. So I have two wireless cards. If I go to status and details, it shows you the IPv4 settings as well as the IPv6 settings, just separate. These are the IPv6 addresses that have been locally that have been generated locally by the client themselves using a process called stateless auto configuration, which I will talk about in a little bit. These are the DNS servers which were obtained and the default gateway that is obtained. Similarly, for my second wireless NIC, you have the DNS servers and the locally assigned IPv6 address. The way clients assign themselves this IP address is through SLAAC address assignment. This is the most common method for IPv6 client address assignment, where clients self-assign an address based on the IPv6 prefix. So the router sends periodic router advertisements which contain the prefix, the router prefix, which network that the client should belong to. When the client receives that, they go ahead and self-assign an address based on that network. So that the router advertising message also informs the client. In addition to the prefix, it also gives the client what gateway to use. And from that point, clients can generate the rest of bits for the IPv6 address. And that's how the client got these IPv6 addresses. So I'm going to go ahead and ping an IPv6 address via my IPv6 DNS server, and I'm getting replies. Another way to test your IPv6 network connectivity is to go to test ipv6.com, and this shows your IPv6 network connectivity status.